All right, this is the second video for this section, and it's completely optional. It's just extra example problems. There's nothing really new here, okay? So if you want, you don't have to watch it, but if you want to see some more examples, here they are. Let's do example 2. I like green, but let's not do green right here. Example 2, find the slope. So right off the bat, stop right there. I haven't finished the problem. Find the slope. Slope, derivative. Have that connection in your head. We're going to be finding a derivative here. So find the slope of f of x equals x cubed at x equals 1. All right. So to find the slope, we need the slope function. Slope function's the derivative. Okay. The derivative, that's not derivative, that's derivative. That's a d, I promise. Derivative is slope. Very important. Okay. So we're going to say, well, what's the derivative? We need to find the derivative. We're going to use the power rule because we've got a nice monomial up here. Power rule says we bring down the exponent, and the new exponent is the old one minus 1. So the derivative is going to be 3x squared. So we found the slope function. But specifically, and this is what's a little new, it says find the slope at x equals 1. So we need to find the slope when x is equal to 1. What we found is the slope formula, right? This is the slope for any x. But we just want when x is equal to 1. So all that's left is to say, okay, well, what is the slope when x is equal to 1? You plug in 1 for x. You're going to get 3 times 1 squared, which is just 3. So the slope of this function, when x is equal to 1, is positive 3. This is kind of what the slope looks like. That's how steep it is. All right, and that's all there is to it. Next one, example 3. Find the following. This is really just about remembering your alternate notations. Find d dx of x to the negative second power. So again, negative exponent means reciprocal. This is 1 over x squared. But we like it in this form because in this form, we can use the power rule, right? We always want x to the r, at least right now. And this is in the right form. So the derivative of this function, remember this just means derivative. The derivative of this expression, I suppose, is, well, we bring down the exponent, and the new exponent, we just have to subtract 1. Simplify that out, that becomes negative 2 times x to the negative third. And that's a perfectly acceptable answer. Or you could rewrite it. And again, just like with example 1, this exponent only is attached to the x. So the negative stays out in front. We get an x cubed in the bottom, because that's what negative exponent means, reciprocal, bottom to top, top to bottom. And the 2 stays on the top because the 2 doesn't have an exponent. So this is another equivalent answer, and they're both good at different times. All right, last example of the video. Find dy dx if y is equal to x minus 2 over 5. This one looks pretty strange, and not just because my 5 looks weird, but this doesn't look like we can use the power rule at all. We're going to have to rewrite this one because it looks kind of weird. So we're just going to use a little algebra trick and rewrite this. Remember, if I have something divided by a number, we can just divide each thing individually. X divided by 5 minus 2 over 5. And it might not be perfectly clear what's going on even now. But let me rewrite it one more time. X over 5 is the same as 1/5 x, right? Because if you multiply 1/5 and x, you write x as x over 1. Multiply the numerators, multiply the denominators, and here we are. Well, this is just a line. So we're trying to find the derivative of a line. And remember that derivative is the slope. Well, all of you at this point know the slope of that line, right? The slope of that line is mx plus b. The slope of the line is just 1/5. All right. So dy dx equals 1/5. Another way of doing this is you actually can use the power rule here, but it involves also like an addition rule, which we haven't really gotten into yet. So we'll just do it this way for now, but later on, there's plenty of other ways to do this problem. Here we go. Yeah, those are some extra problems. More stuff in the next video.